Good morning, everyone, and thank you for being here. My name is Sunil, and I have an experience for almost like 16 years of experience in the networking domain and in the security domain and also in the automation side. So today we are here to discuss about the topic called bridging the layers in the platform engineering in the modern network stack. So, in the next 15 minutes, I will take you through why this topic is so important to us, the challenges we face in today's environments, the tools that help us to improve our security and the deployments and everything else, right? And then finally, some real world strategies and lessons we can apply. Okay. Coming to this matter, why this is so important for us, right? Why this matters for us. Let's begin why this matters because applications today are no longer built as giant monoliths, right? So they are distributed across different regions and different locations and in different cloud environments, right? Some of them might host the applications in AWS, some of them might host the applications in Azure, and some of them might host applications in their on-prem data centers. And there are scenarios where they want to host the applications in multiple cloud environments and also in the on-prem. Depends upon the needs of their business and all those things, right? That makes all clear lines between infrastructure, the networking, and applications, but to blur together, right? Because the requirements are being changing every day, and we have to see how we can make these things align together and make it in a better way to deploy the things. Today, the developers are expecting something different. They want the platforms that are fast, secure, and self-service without needing to worry about the plumbing underneath. So why they don't need to worry about how the network is built at the downstream, where they don't have any knowledge on how the things are deployed, and also the security of the deployments, right? So the shift is focusing to rethink the how infrastructure platforms and networks come together, and that is where the platform engineering enters the picture. Okay, the key challenges, of course, that is not easy, right? The first challenge is complexity with the hybrid deployments, right, where we have the applications being deployed in multiple clouds, and I would say deploying the things in the on-prem, and most probably the how the things are being deployed, and they're very tough to analyze for a developer. And the second thing is the challenge of the security. The world is moving so fast with the zero trust mindset. That means that we have to identify, verify, or record across each and every layer we are deploying the things now, not just at the where the perimeter is deployed. So we have to think we deploy the things more securely for the business owners and for the applications and also for the businesses, right? And also the last but not least, right, the performance of the applications, because the applications being deployed in a multiple cloud environment and also in a different geographical locations. So the third thing is very important is like the performance, right? And the way we are deploying the modern applications, they are very sensitive to the latencies and they want the things to be very fast because some of the financial transactions, gaming, and also the apps, everyone is not ready to wait for a minute also, right? Today, everyone wants the things to be happen in a millisecond. So the performance it's really very important for the applications to function seamlessly. And finally, the developer's experience, right? Reducing the friction for developers is very critical. Otherwise, they will bypass the security controls or build shadow infrastructures just to move faster. Because everyone wants the things to be deployed in a days now, not in months. Earlier, we used to take years even for developing an application, but things have changed so fast, and everyone wants the things to be done very faster, right? And in order to deploy the things faster and securely, we have to think about entering into the platform engineering, right? This is where the platform engineering comes into the picture, right? Thinks of all its glue between infrastructure, networking, and application. Everyone has to understand how the things are deployed at each and every layer, and it's very difficult for everyone to understand those, right? The main objective of the platform engineering is abstracts complexity, automates the repetitive the operations, and also provide the secure self-service platforms. It creates a foundation that bridges the developers and operations teams and also security, right? In other words, it lets developers move quickly while still keeping the network and infrastructure stable and secure. So if they deploy the things faster without thinking about the security aspects of the applications, that's where the real challenge of issue relies, right? Like where people will struggle in deploying the things securely, and there is a chance of people trying to use that loopholes and getting into the networks or exploiting the applications. So this is where we have to start thinking about how do we use actually enable the platform engineering, and what are the tools which we can use today in order to use this kind of a platform engineering where we can deploy the things faster and securely. There are four key tools that we will talk today. The service mesh, which manages the service to service communication, observability, and also policies. And the next one is the API gateways. That's where the security of ingress authentications and the developer friendly access is needed. And the next one is the zero trust models, which makes is sure security is identity driven and continuous. And also finally the programmable infrastructure, things like infrastructure as code and GitOps, which allow us to consistently deploy and manage across the environments, right? Because as I said like earlier, things we are deploying the things in multiple cloud environments, right? And there should be an unique way of deploying the things faster and with the same set of configurations. I mean, to say at the security level or whatever that is, right? So they have to be unique, and we have to see how programmably we can deploy the things and automate the stuff. Service mesh in practice. Let's start with the service mesh. Examples include Istio and Linkerd. These tools sit inside the cluster and manages the east-west traffic and retries in the observability. I'm not here to advertise for any kind of a product or anything like that. So I'm just bringing up a couple of examples for the people who can understand the things, right? So now we have many other applications or the tools in the system or in the environments now, where we can go ahead and pick whichever is more relevant to the businesses. They also bring in MPLS encryption, right? That these tools can bring encryption things, which critically for securing the communications between the services. The key benefit is that developers don't need to build these features themselves. The mesh offloads that complexity, giving them a clean, secure way to connect the services. And the next thing is the API gateway and developers experience. The examples of the API gateways are nothing but like an Nginx, like an Apigee, a Kong, and there are some kind of an open source API gateways as well, which are very user friendly applications as well, gateways which are being used now because everyone don't want to go on with some kind of an like an tools which are not ready to be like an open source, and it's very hard to manipulate those configurations, right? Everyone is looking at some of the open source tools nowadays because that way we can enhance the tools and deploy the things on our own, and also we can increase the security of that if there is anything on there. So some of the people are really looking at some of the open source tools nowadays. We have to think about all these things in for the future deployments and all those things. In practice, they act as this API gateways act as a bridge connecting the external users to the platform and then to services behind it, right? For developers, it makes access simple, controlled, and secure. Because of these tools, the API gateways take care of that kind of an ingress security. And the next thing is the zero trust security. What do you mean by zero trust? Security has to be everywhere nowadays, not just as at the perimeter. That's where zero trust comes in. So earlier, people used to think there is a firewall which is sitting in the entry of our network is the one which is going to secure the things. It's all over now. Just securing at the entry or the perimeter level is all gone. We have to be thinking about more ways of securing this stuff. So this is where the zero trust comes in, right? Instead of assuming that once you are inside the network, you are not safe everywhere. It's every request is verified continuously. This is enabled by identity aware proxies and policy driven access. Examples include the SPIRE for service identity and Google's Beyond Corp models for enterprise access, right? This approach ensures that both users and services are verified before they can touch any resources. Next comes to the programmable infrastructure. Now let's talk about the programmable infrastructure, right? With tools like Terraform combined with GitOps, tools such as Argo CD and Flux, we can make infrastructure reproducible and version controlled. So someone else, let's say that you have a code on your system and someone else is also having a code on their system. We don't want them to be pushing the codes individually and have a different ways of deploying the things, right? So there should be a version controlled way of doing the things with the GitOps and all those things where people know like what the changes have been made by the other developers so that they can think about it and someone reviews and approves the changes with this GitHubs and all those tools so that they don't make any unwanted changes into the environment, which is well structurally built by someone else. So this version control things makes the things streamlined and also lets the developers to do it in a well fashioned way. This is a powerful because it enables trust, self service, because you don't need to do this repetitive task again and again with this infrastructure as a code platforms, right? Now, developers can request infrastructure and the file system spins up it automatically in a consistent way. No more manual tickets, right? So with these tools, we are making everything automated. People doesn't have to go through that entire process when they are starting to build the first application. So now they know the process, like whatever they want it, right? For any application to be built, let's say that you want an IP address for the server or a DNS name and all those things. These are all incorporated into the code so that they all can be happen at the same time. You don't need to worry about these repetitive tasks again and again. So that there are chances then when you go for this kind of a repetitive task, there are chances like people might miss one step in the deployment and there is a chance that people, when they go for a production deployment, they worry about what happened, where did I miss, and what happened over there. So instead of that, these things, these tools really helps us a lot in order to automate this stuff and make it like avoid doing any kind of a manual mistakes which people do. And this repeatable task being performed by this programmable stuff makes the things faster and also in a more secure way. Might be some people might forget to deploy a firewall configuration or a security configuration over there, and it becomes a problem for the security of that application. So this repetitive task should be performed by some kind of an programmable infrastructure so that we don't run into any kind of an issues when the applications goes into the deployment. And the next thing is the design strategies, right? Of course, how we design this platform is really matters because you cannot just blindly deploy anything and then without knowing how the underlying things are working and all those things. First layered abstraction without holding too much. We want to shield developers from unnecessary complexities, but still allow them to visibly and control where needed. Second, consistently across environments, whether we're running it on-prem or in the cloud or at the edge, the platform should look and feel the same. They cannot have a different ways of deploying the stuff when they host it in AWS or when they host it in Google or when they host it in somewhere else, right? Or even at an on-prem. So the thing has to be very same for the user feel and also for the security and all for the other things. And the third one is a secure by design. That means that integrating policies from the start and continuously measuring so we know that what's working and what needs the improvement. Let's jump into the real world examples. To make this concrete, let me share a couple of real world scenarios. One organization was running a multi cloud microservice. They were struggling with both the performance and security. They decided to adopt a service mesh for secure service to service communication, an API gateway for external access, and infrastructure as code for consistency. The result? They reduced mean time disk recovery to 40%, and also perhaps more importantly, develops adoption to the platform increased like dramatically. So that's the power of platform engineering when applied effectively. Let me wrap up. The key takeaways from this one is platform engineering is going to bridge the infrastructures, networking, and the developers, the service mesh gateways, zero trust infrastructure as a code, as the core enablers. The balance is always between the developer's experience, scalability, and security. And the best way forward is to start small, automate incrementally, and measure continuously. And I would like to close it today with saying thank you for everyone for joining this session with me today. And platform engineering is not just a technology trend, it's a shift in how we design, operate, and secure modern applications. If there is one thing I would like to leave you with, it's a bridging the layers is about more than tools. It's about enabling developers, operations, and security teams to work together seamlessly in modern network stack. And thank you, everyone.